who are here for the first time, Women in Logic is an initiative aiming to promote women that work on logic and applications of logic. So the talk is for the seventh talk of the Women in Logic seminar, is hosted for the last time by the Vienna Center for Logic and Algorithm, which is an initiative which was funded by the TU Vienna, which aims to promote research in logic and algorithm, but also outreach and also women in STEM. So because we do not have funding anymore, the next talk from the Women in Logic seminar will be hosted by the UCL, and actually Elaine, who will be the new responsible for this Women in Logic seminar on talk today. So thank you very much, Elaine, for taking it over. Also very talk. But before I will present. So I would like anyway to thank a lot Josephine for helping me with the organization. Normally she introduces the speaker, but because this time Australia, where currently is 2:00 in the night, she asked me to present Elaine, which is kind of straight. So first of all, can someone sharing so that Elaine can already start putting her slides on the web page?
Okay, I'll drop the screen.
So it's a great pleasure for me to introduce Elaine, but it's also kind of embarrassing. She's not only a great scientist, but she's also one of my best friends. So it's kind of about her only from the scientific point of view, but this is what I'm going anyway to do. So Elaine, she's a professor of logic and computation in the Department of Computer Science at the University College of London. And before, she was a professor in Brazil. She is doing a lot of initiatives, and honestly, I don't know how she managed to do all the things that she does. So she's outreach lead of the UCL. She's the treasurer of the ACM SIGLOG. She's the chair of the Latin American Committee of the Association for Symbolic Logic. She's also the chair of the steering committee of the two conferences, Tableau and LFMTP. And she's also involved in many outreach projects. So, plus she does excellent research. So, Elaine, I don't want to continue saying, because I could say a lot of other stuff about you, but let's make you talking. The floor is yours, and thanks again for accepting the invitation.
Thank you, Agatha, for the very sweet words. I feel the same. I mean, it's a pleasure. It's also kind of strange because we are among friends, right? So it's really good to be among friends and to talk about research at the same time. Let's do it. So I was thinking about, first of all, I mean, the Women in Logic is very special for me, and for many reasons. And these online seminars that Agatha started with Josephine and Andrea, I think it's brilliant because we can collect talks of different women talking about different stuff. And normally they are talks that are meant for a bigger audience, so anyone can follow and understand more or less what we are doing. I have fun with this meeting, so I'm going to have fun in this one as well, even though I'm talking. So I'm going to talk about ecumenical. I decided to talk about ecumenical systems only because it's a broad area that I can talk about many things. Also because it's something I'm still working on. So what I'm going to present some things that I did in the past, but also things that we've been doing now, papers that we're publishing or submitting or things like this. And this is a joint work with many people. So for example, Luis Carlos mainly because he was the one who introduced me to this, and Valéria de Paiva, Sonia Marron, an ex-student of mine, Emerson, Victor, who is the postdoc working with us, Carlos, who is my husband and my best friend, and Joaquin and Maria, who are my PhD students, and I'll put etc. because it's a lot of people. Okay, so let's start with the ecumenical system. So I'm going to give you first some motivations. The first one is the eternal debate, ethical and intuitionistic. So the idea here to talk about philosophical views of validity in classical and intuitionistic logic, and how do this kind of thing is going to reflect on the nature of being of controversy for a long time now. And this intuitionistic advocates for a strictly constructive notion of proof, while the classical logician is going to advocate for a notion of proof where we can use non-constructive principles, like, for example, the reduction. So what Dr. Prawitz did in 2015 was to ask the question, connective, classical, or intuitionistic, and of course, how this is going to reflect on the proof we're going to have, the logical proofs that we're going to have afterwards, okay? So this is one thing that I'm going to talk about. So this was really the beginning of the ecumenical agenda, let's say. Then we're going to move up, we're going to move to a different kind of perspective of ecumenism that we're going to talk a little about. Okay, so there are at least two central issues in constructive logic. One is the nature of refutation. So what does it mean to refute something? And the second one is how falsity can be represented in a constructive framework. There are many ways for answering this question. So what we're going to do is to see this via an ecumenical kind of glasses. And the work that I'm going to present briefly is based on David Nelson's work, where he has two kinds of falsity. One is called weak falsity, that it's just going to describe a procedure that's going to transform any construction of a mathematical object into a contradiction. And he's going to represent like this, as we normally represent negation. And you have strong falsity, where for something to be false, you have to explicitly construct a witness of this falsity. So let me just, and this you represent with this tilde kind of connective. So let me just give you a real example, or let me give you a constructive example of this. So the first one, the weak falsity, it's something like you assume that X is equal to Y, and then from there, you're going to derive a contradiction. While the strong falsity is stronger in the sense that you have to construct really two elements or two objects, X and Y, such that X equals Y does not hold. Okay, so this is the difference between these two notions, Nelson's notions of strong falsity, and the idea of ecumenism that I'm going to show you today is how do you combine these two things in a same system, where you maintain the consistency of the system at the same time. Okay, so this is the second motivation. The third motivation is purely mathematical. So if I have a very straightforward sentence like if X plus Y is to Z, then either X is greater or equal to Z, or Y is greater or equal to Z. And how can we read the sentence and make any sense out of it, okay, classically and intuitionistically? So starting with intuitionistic view of the sentence, if you try to prove this using only constructive methods, you're not going to be able to. So the classical mathematician and the intuitionistic mathematician are not going to be happy because they're going to look at this and this is not going to be true, okay? Now, if you put a not, so if you double negate the same assertion, so actually what you're doing is to flip from intuitionistic to classical, so you're going to put the classical lenses or glasses, then the classical mathematician is going to look at this and is going to say, okay, this is true. I can understand this and I can prove this. And the intuitionistic mathematician is going to say the same. This is okay for me as well. I can see this and I can prove this. This is okay. This is a theorem. Okay. But is this the best we can do? So we can do better, actually, right? I mean, we don't need to be that strong because we can, for example, put the implication only intuitionistic, so constructive, and while the disjunction or the or has to be classical, right? So if you have this mix of things of reasoning, intuitionistic or constructive reasoning and classical reasoning, then you can prove this. And the classical mathematician is going to be happy because it's going to make a lot of sense. And the intuitionistic mathematician is going to be super happy because now the person is going to know exactly where the double negation has to be done or has to be put, okay? Not in front of everything. You can restrict this to a little piece, okay? Okay, so this is the motivation in mathematics that I'm going to talk a little bit about. And I'm going to base this on the work of Krauss, where he said that we don't have to be classical everywhere and all the time. To show you some more elaborated examples at the end. And finally, I'm going to talk a little bit about Glivenko. And the idea is based first on the proof of by Kolmogorov and others that classical propositional logic can translated into intuitionistic propositional logic. And this translation was defined as a function from both. And this function preserves some very important properties. So, for example, like theoremhood or derivability. So Glivenko, what he did was to prove these two theorems, saying that if A is a classical theorem, a propositional classical theorem, then not A is going to be an intuitionistic intuitionistic theorem as well, propositional intuitionistic theorem, and vice versa. Okay, so this was the first theorem, Glivenko theorem, and the second one says that theorems of the form not A, or not A is the negation of A, the weak falsity of A, you cannot distinguish not A in classical or intuitionistic logic, okay? So the question is, okay, now when I'm going to talk about ecumenical systems, so I'm going to talk about classical and intuitionistic, I'm only going to have one framework or one language, but can we have like a Glivenko kind of view inside ecumenism as well? So this is going to be the fourth part of the talk. So this is going to be the last thing that I'm going to talk about today. But then, okay, so I've motivation, but what is ecumenism? Okay, so first of all, it comes from the Greek oikumene, that means the whole inhabited world, and the idea is really to find of unicity, where you can have different thoughts, ideas, or point of views existing harmonically. So the questions, and now I don't get these questions anymore because I think that people are more or less used for me to talk about this, or other people to talk about this as well. But the questions that we had at the beginning, for example, was what are really ecumenical systems? What are they good for? Why I should care at all? And what's the real motivation behind the development of such systems? So so this talk is really about this line of questions, and answering this through at least four different perspectives or views, or reasoning with four different angles. And we'll start with classical and intuitives a la Prawitz, then talk about falsity, then talk about quantifiers and the work in mathematics of Krauss, and then finish with Glivenko. Okay. So let me just start the warming up. And this is when we are teaching, or when we're giving talks for the first time for people that never heard about what intuitionistic logic is, we always start with the same example. At least I do. It'll be this theorem that there exists two irrational numbers such that one to the other is rational. So normally when I present this to my students, for example, they keep thinking like this, how this is possible, right? two irrational numbers such that one to the other is rational, right? And I tell them, look, this has a very simple proof, and the proof is this one. You just consider square root of 2 to the square root of 2. If this number is rational, you're done, because you just take both of them as if your witnesses or your irrational numbers, such that one to the other is rational. But there's the other possibility, of course, that this is not rational. So you're going to take actually x as being this not rational number and y as being square root of 2. And then, of course, if you do one to the other, you're going to have 2. Okay, so this is a very simple proof. Kids at the end they understand, they're really happy because it makes sense, and etc. But then the question, of course, is, okay, is this a real proof, right? So the classical mathematician, again, is going to say, oh, okay, this is really cool and fantastic, as my students do. But the intuitionistic mathematician is going to say, okay, wait a minute, but which one is the case, right? Is the case that A is rational or not? Okay. You can try to move over this problem of saying, okay, you can go to Hilbert's seventh problem, for example, that says if you have two numbers, two algebraic numbers, such that the first one is not 0 or 1, and the second one is not a real rational number, then one to the other is a transcendental number. Okay, so if you take this problem and then you say, okay, if you believe in this, you take alpha and beta as your irrational numbers, right? They are going to fulfill this. And then you know that alpha to beta is transcendental, hence irrational. Okay, so you know the answer for this. You can give the answer for the intuitionistic mathematician. Okay, it's the second case. It's not rational. Okay, is this okay? Well, not really, right? Because I'm telling you, this theorem is true. This is a theorem. Okay, it has been proved a long time ago. Okay, so but how is the proof, right? Is the proof constructive or non-constructive? Because if the proof is non-constructive, then the intuitionistic mathematician is going to say, okay, I don't believe this, okay? So you see, I mean, this is a kind of a game that you have to keep going backwards until you have to be sure at the end that what you're doing is really based on constructive steps. And you can take a look at this proof. It's a long proof, so I'm not going to put this to you. Just to notice that you go on, it's more than 20 pages of this very nice book by Ivan Niven. And when you go to the last lemma, you have that this is a proof by contradiction, for example. So yeah. So see, I mean, this can be as complicated as one want it to be. Okay, so let's start with how Prawitz decided to take a look at this problem of, the contrast between classical and intuitionistic, and how he wanted to make everyone happy. Okay, so his idea starts with the following. So for a classical logician, you have that A or not A holds. For intuitionistic logician, this does not hold for every A. And the question is where and why they do disagree, okay? So one way of seeing this is just using proof theory. I mean, you can take the proof in natural deduction of A or not A in classical logic, and you can try to do the same in intuitionistic logic, and you see that you're going to fail. This is a finite number of things that you can attempt. So so then you're done. I mean, you know for sure that this is not provable using natural deduction, for example, in intuitionistic logic, and you have a proof in classical logic. So they're different. Okay. So what Gensen said that is that, okay, they are different because actually disjunction is different, right? So for him, if you take the system that you have for intuitionistic logic and you change it a bit, so you put, instead of having a single conclusion sequence at the end, you allow it to have many formulas, then to turn to classical, and then this disjunction is going to be the comma on the right, more or less. Okay, so disjunction is the difference. And then Mahara said, well, I mean, you can have systems where you have multiple conclusion as well, so as Gensen had for classical logic, so it's fine. You can still be intuitionistic, it's fine, but then you just have to take care of the implication. The implication rule in the propositional case. The implication rule is going to be different from classical and intuitionistic logic. Only that, okay? So you only have a difference in the implication. Okay, disjunction is the same, so you don't have a problem. Disjunction in comma on the right, it's going to be the same thing. Okay, as in classical logic. What Prawitz said, on the other hand, is that actually both are kind of problems or are kind of different. They're not the same connectives, okay? So his idea was this. So he said, okay, the classical and intuitionistic logicians, they are not talking about the same connectives, both in the case of disjunction and the case of implication, in the first order, also in the case of existential quantifier. For all the rest, they are talking about the same thing. They have the same kind of understanding of the meaning of these things, okay? So I love this sentence I took from his paper, is that the classical logician is not asserting what the intuitionistic logician denies. The classical logician asserts that A or not A is valid classically, to which the intuitionistic logician does not object. He agrees with that. He objects with to the universal validity of A or not A intuitionistically or constructively, which is never asserted by the classical logician. Okay, so they're not really disagreeing; they're just talking about different stuff, and that's it. So once you see things this way, you can find a way of supporting both ideas without fighting, and this is exactly what he did. Okay, so. As I said, I mean, they're going to have some connectives that they're going to be the same. So universal quantifier, conjunction negation, and the constant for absurd. But they are going to have their own existential quantifiers, disjunction, implication, and they are going to have different meanings. They are going to be completely different connectives, okay? Fantastic. It's really surprising that although we have two implications, we only have one negation. There are reasons for that, but I'm not going to enter into details of that. This has been a source of debate for some time now, especially with Valeria, but I think that we're more or less converging to some explanations of how and why things are like this. Okay, so just to present you really quickly so we can move on. Idea is, as I said, I mean, to have shared connectives, and I just put here the ones, the introduction ones for negation, conjunction, and a universal quantifier. You have the intuitionistic version of some connectives, so I put there the introduction rule for them, and you have the classical version for them that I put the introduction rule for them as well. Okay. So what we did with Valeria and Luis was to take a look at this and try to reason better about provability, not only about the system itself or philosophical grounds and things like this, but also on, put the hands on really and try to see what you can prove, what you cannot prove. And I'm not going to enter into details and why things are like this or like that. And for doing that, we move it to sequence systems instead of natural deduction. And then we could prove meta level theorems, like, for example, that something is provable in ecumenical systems if and only if you have that the conjunction of the hypothesis implies intuitionistically the conclusion, and things like this. So the entailment is intuitionistic. But if you have a conclusion that is classical, then the entailment moves to classical, and then you have a very fine and cute way of having or grabbing the ecumenical behavior of the system. Okay, so we have a very nice explanation of Prawitz's philosophical ideas using proof theory. Okay, so this was in 2022, and it was really a really fun paper to write with Valeria and Luis. So let me just move on to the next subject, but before, let me talk about some other things that we did that I'm not going to talk about. So the first question is, okay, Prawitz start this agenda with classical and intuitionistic, but can I do something else? And the term ecumenical, and by the way, ecumenical has nothing to do with religion. It's not attached to logics, okay? It's just a way of having a framework for reasoning about different stuff. Is it what Prawitz did was not just double negation translation? And the answer is no. We have a paper dedicated to this that appeared last year in Studia Logica. Can we handle modalities? Yes, we have many papers dedicated to that with Sonia and Luis and also Emerson. And finally, why should I care? Well, if you don't like my agenda, for example, Pravitz's agenda, or the people that have been working with this now, you can trust some other people. So there is this whole agenda of combining logics that has something to do with ecumenism, but not really quite. That is, it's a very big agenda with very nice people working on that, and etc. There's the work of Krauss to try to reason about constructive and classical mathematics that I'm going to talk a little bit about today. And there's also the work in automated deduction by Gilles Dweck, Frédéric Blanqui, and colleagues, where they try to make different kind of proof assistants to communicate. Okay, I'm not going to talk about this because I think that we're not going to have time to explain things. Just to tell you that we can do more, like proof theoretically, we can do more. So, for example, if you take Prawitz system, you're going to see that you from time to time you have to put negations everywhere, even though what you want to prove has no negation at all. So, what's negation doing there, right? And the idea is that his system is not pure because you need to use negation to define the classical connectives, but we can move on from this as well using polarities and Stoop. I'm not going to talk about this today. This is a work that Luis Carlos and I did some time ago. So, but the idea is just that you have like instead of having one formula, you have a separate like places where you put formulas, and then you don't need negation at the end, okay? You have a system that looks like Prawitz's, but it's not, because you can see you don't have negation anywhere. And actually, you have a very nice way of moving from one system to the other, okay? Okay, so this is cool. So we have also purity and et cetera, et cetera, et cetera. We can prove now our Peirce's law without negation. We can do more. Instead of having only classical stuff, we can mix things, intuitionistic and classical. The only thing is that the last implication has to be classical, and we have no negation, okay? So this is I think that this is only to finish. We did a lot of things on the top of this, normalization, Curry Howard, proof theoretic semantics. I'm not going to talk about this today. Let's move on to negation, because this is one of the works that I've been doing lately that I'm really enjoying myself. And I think it's cute. And I think that it brings to the spot some ideas that are not really well known, or people don't talk much about it. And also, it's a pleasure because I'm working with two people that really like love, I would say, Victor and Maria. So the thing is, this dichotomy between weak and strong negation that I talked at the beginning. So weak negation is the negation that we are used with. That if we have if we assume something, we construct a falsity out. We take a falsity out of this. And so, and strong negation where you need witnesses, okay? So the nice idea about this, to see this, in my view at least, is that if you have a counterexample, right? If I give you a counterexample of something, then you can with that you have a procedure for reducing the construction of this thing to a falsity, okay? So if I provide that phi of A does not hold for an A, and if I assume that phi of X holds for everywhere X, then we have a contradiction, okay? The other way around, though, it's not the case, right? I mean, if I give you a procedure of reducing a statement to a contradiction, From this, you cannot construct a counterexample for that statement, right? So this is the thing. So if I assume phi of x and this leads to a contradiction, it does not follow that I can find a specific object to which this formula is going to fail. Okay, and this is translated in intuitionistic logic that not for all not for all phi does not imply exists x such not phi of x. Okay, so this is not valid in intuitionistic or minimal logic. This is valid. I mean, these two things are equivalent in classical logic. The existence statement implies the negation statement in intuitionistic logic, but not the other way around. Okay, and the reason is this. Okay, well, but we can using this strong negation, so using this notion of giving the witnesses of the counterexample, we can actually recover this kind of equalities. Okay, so if I have a proof of not for all phi, then this not is a very strong one. So I have to find an A such that phi does not hold. And then, of course, if I find this A, I prove it that there exists an X such that phi is not valid for that X. Okay. So with the strong negation, I can make these two things be the same again. So I recover that classical equality that I had there, and that is not valid for intuitionistic logic. Okay. And the reason, of course, is because you give a counterexample. So you give the witnesses, you construct it, okay? So you have the equivalence again. But the reason why these two things are equivalent is completely or entirely different from the perspective of the strong negation and from the perspective of the classical logic. In classical logic, these two things are equivalent because the existential statement is really too weak. So you don't ask much. While in the strong negation of Nelson, these two things are equivalent because the negation is really strong. Okay, so I think that this is really interesting. So at the end, you're going to arrive at the same point, but with very different paths. Okay. Okay. So the thing is that this strong idea of negation is really closely related to bilateralism, and I'm going to explain exactly what it means. And if you want to constructively prove phi, you just have to provide a proof that is constructive for this thing, right? And if you want to prove not phi, where not is strong negation, then you have to find a counterexample to phi, okay? So for Nelson, this is the same as saying, okay, putting the contents of positive and negative statements, this is going to be put on the same ground, okay? And this is exactly what bilateralism does, okay? So you have positive and negative statements that they are not taking as mutually interdefinable. Okay, and Vansing, well, there are many people that, so this didn't start with Vansing, of course, but there are many people that studied bilateralism, and actually what I'm going to talk about is based on the work of Vansing, that, so he studied bilateralism through the views of being bi-intuitionistic logic, and yeah, and the idea was more or less to capture this notion that Nelson was talking about up there, right? If I want to disprove a formula, then this is going to be the same as proving the strong negation of it. And if I want to disprove the strong negation, this would be the same thing as proving the formula, okay? So you have these ideas of proving or disproving and the negation being put together in the same place. Okay. What we did though was to construct a system, a natural deduction system that's going to talk about this, but where you don't have you cannot construct inconsistencies out of these ideas being put together. Let me explain to you better what do I mean by that. So the first thing that we have to note is that when Nelson's system was first proposed, it was not compositional, at least in two ways. So let me just point out why. So the first one is that you need to display two connectives at a time, okay? So if I want to apply this rule here, so bottom up, as we do in proof theory, you see that you need to have a negated implication, right? So you're combining two connectives at a time. This is not really desirable in proof theory. The second thing is that you don't have this subformula property, okay? So if you want to, you have rules like this one where you have the negation of a conjunction here, for example, and here you have the negations of a formula, something like this. So you don't have subformal property as well. So what Vansing did was to see this with different eyes. So put the glasses of bi-intuitionistic logic and having proofs and refutations. So you can read this really easily. So whenever you have a strong negation, you put a refutation symbol that is just two bars here. Means that I'm going to refute psi, okay? And whenever you don't have anything, you just put one bar, okay? So you can see here you have a negation, you have double. Here you have a negation, you have double bar. Here I have a negation, double bar. Here I have a negation of something being discharged, so I put the double bar in these brackets that I'm not going to explain. And all the rest, I just put the normal inference bar that we are used with, okay? So you see, I mean, from here to here, you avoided, Vansing actually avoided the two things at the same time. So now you have subformal property, and you have you don't need to talk about two connectives at the same time. You have a price to pay, of course, but it's completely fine. Okay. What we did was to build over this work and to find a system, a proof system that we call BPR, where a formula cannot be provable and refutable at the same time without producing a contradiction out of it, okay? So the idea is simple. So we just add two rules to the system, to Vansing's system. That'll be this one, that if you can prove and disprove something, then you can prove anything, right? And I'm sorry, prove and refute something. And if you prove and refute something, the same something, then you can refute anything. So you have an explosion there for provability and also for refutation as well, okay? So it's just this little change, just these two rules there, just that, okay? And the rest is exactly as Vansing proposed, his fantastic system, okay? So when we do that, now we have a framework. It's ecumenical because we can talk about both negations, the weak and the strong negation, in the same system. And this is really good or suitable for modeling mathematical proofs and refutations that excludes inconsistency, okay? So now we have a system that can talk about mathematics without bringing together inconsistency, which I think is pretty cool. I'm not going to enter into details of that, just to say that we can capture, like, proof theoretically that notion that I said to you, that if you have a strong negation, then you can build a constructive proof of not a formula using the strong notion of negation, and you can do that in the proof system, okay? You can do more, actually. You can do normalization, subformula property, you can prove consistency, both for proofs and refutations. You have a semantics based in proof theoretic semantics. And this is a very nice, I think, at least, or paper that I wrote, that Victor and Maria wrote with me. Okay, fantastic. So we're moving towards the end of the talk. The last two things that I have to talk about are really quick. The first one is mathematics, and this is not really my work. This is based on Krau's work. We've been working over his ideas, and his idea is exactly this: that if you are a mathematician and you want to prove things classically, you don't have to double negate everything. So there are some parts of the proof that you can do it constructively, and some parts of the proof that you need to be classical, so you need the double negation. And he was really keen on finding exactly where in the proof you should be one or the other, or you could be the other. And his idea was to more or less the same as Prawitz kind of idea, although they came from different perspectives completely. But they have some differences. So, for example, Krauss has two conjunctions, a classical and an intuitionistic one. Prawitz only has one. But then Krauss notes that a mathematician never uses this. Because from A and A, you cannot prove A, actually, so it's not idempotent. You only can prove not A. For the classical mathematician, it doesn't matter because, for the classical mathematician, A and not A are the same formula, okay? But this is a point to Prawitz, because I agree with Prawitz that, yeah, you don't need this. This is really too much, and let's just, as French say, laisse tomber. Okay. On the other hand, Krauss has the ecumenical notion of classical notion of a universal quantifier. So these are the rows, and he can easily prove this thing here that I said at the beginning, that in intuitionistic logic you cannot prove, and also in Prawitz logic you cannot prove. That would be not for all implies the existence of not. Okay. So in Krauss system you can prove it. In Prawitz, you cannot. This is a point to Krauss, okay? So as you can see, I mean, there are different ways of seeing things. And even in the classical and intuitionistic view, different systems, different views, and different motivations. I'm just going to finish this part saying that just to show you how Krauss really used this in practice. So he has three formulations of the axiom of choice, axiom of countable choice, axiom of dependent choice, and constructive axiom of choice. I'm not going to talk to describe this to you. It's the axiom of choice with variations. And what he did was to take this three and say, okay, let's have an ecumenical view of this thing and see exactly where in these axioms you need to be classical. And of course, you only need to be classical in the existential part. All the rest, you can be intuitionistic, okay? Okay, so this is his work, and what we can do with that, well, we've been revisiting his work, and we proved normalization. We have a sequence system, proof theoretic semantics, and a prover with Carlos. We're now building an ecumenical theorem prover. Okay, to finish the talk, I'm going to talk really quickly about Glivenko. So maybe you all know, I don't know, but the Glivenko theorems are two, and the first one says if something is provable in classical propositional logic, then the negation is provable in intuitionistic logic. Of course, you have to translate the connectives from classical to intuitionistic. And the second theorem, which is just it's a corollary of the first one, says that if you prove the negation in classical logic, then you prove the negation in intuitionistic logic. This is, of course, is an if and only if. It's obvious that we cannot have this in Prawitz ecumenical system because we only have one system, not two. Nevertheless, we can see how we can interpret Glivenko inside the ecumenical system. And for doing this, we just take a formula that has a classical operator. We just write this as translating this operator into intuitionistic version of it. And then we can prove in ecumenical system that the classical version of the thing implies the not intuitionistic version of it. Surprising is just to show to you that we can talk about different things in proof theory inside the ecumenical perspective. Of course, we can do the same with the second one. And this is a paper, it has been accepted, but not published yet. Okay, I think that's it. So there are many things that we can do. So for example, we can talk about real ecumenical mathematics. So we can revisit, for example, the axiom of choice and see how we can talk about this using operators of classical and intuitionistic or beta ecumenical operators, not only with this, but with really. There are many applications to computer science. As I said, I mean, there's this whole agenda of the WEC and Blanqui and colleagues of translating things between different proof assistants using didactic and using the notion of ecumenism, actually. There are many new ecumenical codifications. So, for example, from intuitionistic minimal logic, from intuitionistic and S4, and actually a general idea of how can you use translations to talk about ecumenical systems and applying this to classical logic and paraconsistence logic. There are many works going on in semantics as well. I'm not really a semantic kind of girl, but I don't know what happens. Lately, I'm only working in semantics in many different directions, which is weird, but well, nevertheless. And so we have many ongoing works on this as well, and etc. So I would like to thank you very, very much for listening to me. And obrigada in Portuguese, gracias en español, and merci in French. And I think that I covered all my colleagues' languages that collaborate.
Thanks very much. Thanks very much for a very, very, very nice talk. So if you have questions, please write it in the Q&A and I will read to the speaker.